Hello friends, this is Jim with Science Talk. This is a report that I discussed with you guys before. It involves the Antarctic glacier known as the Thwaites Antarctic Glacier. This is kind of an update on that. Basically, British and American scientists are teaming up to research the melting of this glacier, and what they're basically saying is a race against time. Thwaites Glacier, which is found in West Antarctica and is difficult to get to, and I'll talk more about the logistics of that later on. But it is a very good sized glacier, and if it melted, and it is melting, it will significantly affect global sea levels. It already drains an area roughly the size of Britain or the U.S. state of Florida, and does account for approximately 4% of current global sea level rises. This is an amount that's doubled since the mid-1990s. Its collapse would then destabilize other parts of the ice sheet. So it's not basically a question of if, it's more of a question of when this will melt. So, Thwaites and its neighbor, the Pine Island Glacier, could ultimately lose all of their ice. If this were to happen, all of the ice, the estimates are anywhere from 1 to 3.5 meter increase of sea level, basically 3 to 11 feet. That's going to impact a lot of coastal cities around the planet. Scientists have known and have demonstrated for more than a decade that Thwaites, the region, is an area undergoing massive change and rapid ice loss as global temperature continue to increase. The two glaciers, Thwaites and Pine Island, among the two fastest moving glaciers in the Antarctic. One of the scientists involved in the research is Dr. David Vaughan. He's Director of Science at the Cambridge-based British Antarctic Survey, BAS. Professor Vaughan stated, "Understanding sea level rise is the front line of climate change, and sea level rise doesn't happen overnight." Basically what's happening in Thwaites is not an emergency this year, but it will be. Because, he says, "I'm very glad we're doing a research this decade because we can't wait too much longer." So, they're spending approximately 20 million pounds, which is about 27.5 million US dollars equivalent, the research collaboration. So we have from the UK, the Natural Environment Research Council, NERC, and the US National Science Foundation, NSF. And they're going to send teams of scientists, about 100 scientists, to Antarctica to gather the data needed to understand what's going on. There are currently 8 large-scale projects underway, and they're bringing in, so the UK and US are leading it. They're bringing in scientists from other nations, such as South Korea, Germany, Sweden, New Zealand, Finland. Okay. And they're going to form what's called the International Thwaites Glacier Collaboration, or ITGC. There are signs that the process of Thwaites collapse has already begun. Antarctic glaciers add to sea level rise when they lose more ice to the ocean than they gain from snowfall. And they already do not get a lot of snowfall. To fully understand the causes of changes in ice flow requires research on the ice itself, the nearby ocean, and the Antarctic climate. Now, I did a video earlier where I talked about what happened when the glaciers ground down on the seabed, past the shoreline. And I talked about some of the critical factors there. please go and check out that video if you have not seen it. If you have seen it, then go watch it again to refresh the information. So the collaboration will use drills that can make access holes 1,500 meters into the ice, okay, as well as other latest technologies and equipment. Autonomous submarines will be used as well. NERC is funding the UK share of the project. It's being coordinated by BASS, as well as the NSF, and the National Snow and Ice Data Center, or NSIDC, which is out of Boulder, Colorado. As well as the cost of the research itself, the physical problems of mounting a scientific campaign in one of the most remote places in Antarctica could cost as much, again, in logistical support. You got to get the equipment out there. That's expensive. Then you collect your sample. You got to ship the samples out there, ship it in a way that does not compromise the integrity of the samples. So you got to get the equipment, you got to get the personnel out there. And equipment isn't just the scientific equipment. You got to have tents, housing. You got to have a support staff. Who's going to cook the food? How are you going to get the food out there, the water, and so on? Housing material. This is a huge, major undertaking, but it is necessary. So this is what I mean by logistics being challenging. And having, now I've never gone to Antarctica, but having gone up to Point Barrow to engage in research, yeah, just to try and get the logistics, get everything shipped out, arrange transportation, is a nightmare. It's not easy. So the 5-year program will begin in October of this year and will continue to 2023. The data will be archived and freely shared, which is cool. So, other information about this study, okay? They're going to use, I've mentioned before, research ships, submarines, aircraft. They're going to have 100 or so scientists from numerous countries. Currently, climate models have indicated a 1 meter rise would significantly increase the frequency of devastating storm surges, such as what hit the eastern coastal towns of the UK in 2013. But if there's a rise of 2 or more meters, this is going to be very, very bad. You're going to could potentially cause permanent changes to the British coastline, with settlements such as Hull, Peterborough, Portsmouth, and parts of East London and the Thames estuary of becoming submerged, boom, underwater for good. Scott Borg, who's the NSF Deputy Assistant Director for Geosciences, said, "What happens in the Antarctic doesn't stay in the Antarctic." And as I said, where they're going to is about 1,000 miles from the nearest permanent base. 1,000 miles. And the glacier itself is one of the most challenging environments on the continent. They anticipate moving more than 200 tons of scientific equipment. That's going to be a lot of plane air flights. And here's the interesting thing. They're going to employ seals. They're going to fit head-worn sensors on seals and have them swim about. And the sensor's probably going to make a film record of what they see, presumably where the ice shelf's meeting the seabed. That'd be kind of cool. So, give you a perspective of the dangers of these two glaciers melting completely, or even if they don't melt completely, just a good partial melt can be devastating. Sea levels are currently rising by 3.2 millimeters a year. So, if Thwaites and Pine Island glaciers do not melt at any faster rate, the estimation is that sea levels will rise by 30 centimeters by 2100. Well, now, if these two glaciers do melt partially or totally, we're talking 1 to 3.5 meters. So we've gone from millimeters to centimeters, that's already an order of magnitude. Centimeters to meters is 2 orders of magnitude. So we're not talking 3 orders of magnitude increase sea level. That is not insignificant. Around 50 billion tons of ice is already draining into the ocean as meltwater, accounting for around 4% of the global sea level rise that I mentioned at the outset. That amount has doubled since the 90s, mid-90s. One of the scenarios the team will be looking at is what's called the rapid runaway calving, which is tall ice cliffs at the edge of a glacier just splitting off and right into the water, similar to what we see taking place in Greenland. So, as I said, this is one of the stories I'm following, one of the researches I'm following, and as more information becomes available, I will be sure to bring you the updates. Thank you for your time. Thank you for watching. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below.